Hello, here's your help video for number 6. I just wanted to go ahead and work that solution out for you. Just taking a look at the problem. We're trying to find the sum of two rational expressions. And the first thing we're always going to do when we take a minute to try to find that sum is, factor and reduce where we can. So I look at this first rational expression, 3n over 2. Nothing's going to reduce there. However, what catches my eye is the bottom of this fraction. I can actually factor that by pulling out a greatest common factor and then perhaps AC grouping. The goal in factoring that denominator would be to hopefully reduce something in the numerator. In reducing, we make the problem just a little bit easier to work with. So let's get started. So I did. I factored that denominator. 2n squared minus 6n minus 8 has a greatest common factor of 2. 2 goes into 2, 6, and 8. So I went ahead and I yanked that 2 out. The quantity left behind is then n squared minus 3n minus 4. Now, I took a moment to observe that I had a quotient of 6 and 2 just chilling in that second rational expression there. When you reduce 6 over 2, that 6 on top just is 3. However, the trinomial left behind is still factorable. Factors of -4 that would give me -3 are just -4 and +1. So I went ahead and I factored that bottom. So now I do have a little bit of an easier problem to work with. However, the denominators of these two rational expressions are still different. So I actually do need to take a moment to find the LCD. It's kind of nice though, at least my denominators are already factored. So in finding the LCD, I'm going to bring down the 2, and I need both the n minus 4 and the n plus 1. So I'll go ahead and write my LCD. Oops, sorry. Get that out of the way there. My LCD is just the product of 2, n minus 4, and n plus 1. The goal in finding this LCD is to get these denominators to be the same. I can't really add the fractions together unless, I have a common denominator there. So in my next step, I basically just copy the problem and I insert the missing factors from the LCD that weren't in the original denominator. So if this first fraction was 3n over 2, I was missing the n minus 4 and the n plus 1 from the LCD. So I needed to insert those factors that were missing. And then what we do to the bottom of a fraction, you have to do to the top. I did the same thing in the second rational expression there. I had to multiply the bottom and top by 2. 2 was the missing factor in the second denominator when I compare it to the LCD. So now my denominators are the same, which is awesome, because now I can distribute. So essentially to distribute, I FOILed n minus 4 and n plus 1, and I get n squared minus 3n minus 4. And then I just multiplied 3n times 2, and that gives me 6n in that second numerator you see there. Almost done. I can't quite add yet because I don't have terms. I still have 2 factors in that first numerator, so I'm going to go ahead and distribute the 3n in. And that'll get me a good-looking numerator there. So I end up just having as my numerator 3n to the third minus 9n squared minus 12n plus 6n, and then -12n and 6n are like terms. So that's kind of awesome because I can combine those, leaving behind my final answer. So final answer to the sum of these two rational expressions, we have 3n to the third minus 9n squared minus 6n all over 2 times n minus 4 times n plus 1. And then I check that with the answer up there on top. And I'm a pretty happy camper because it matches. So hope this video helps. Holler at me if it does not.